right, people who are leaving or gone or whatever, this is 8-7. We are going to do all of this except for the last example, which we'll spend tomorrow doing, okay? So, starting with example 1. We're talking about what makes decisions, or like how we can make decisions using probability. Got it? Shh. You be quiet. Okay, we want to first and foremost make sure that when we're using probability, or when we're using our dice, or when we're flipping a coin, that everything is fair. And fair only occurs if all the outcomes are equally likely to happen, right? So if I'm flipping a coin, or flipping my pen in the air, if I'm flipping a coin, I can only do that fairly when I'm like picking between two things, right? Okay? And so on and so forth. So I have to make sure that the way I've set up whatever it is that I'm doing has to be fair. All right, so example 1. This is kind of a tricky question. There are 4 people that are on a team, and they are Khalil, however you pronounce that, Amy, Diego, and Jenna. Those are the 4 officers on the school's video club. They need to choose one of those officers to attend the meeting of representatives from all of the school's clubs. So one of those are going to be elected. And we're going to figure out how to decide fairly which one goes. So all 4 officers, that's supposed to have an E in the middle of it, officers would like to attend the meeting, but they propose that instead they flip a coin 3 times to decide who gets to go. Okay? So this is what they've decided. They say, okay, when we flip those coins, when we throw 3 coins in the air and they land, if we have all of them being tails, meaning no heads come up, all 3 tails, 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 then this person gets to go, okay? If there's 1 head and 2 tails, that means Amy gets to go, right? If there are 2 heads and 1 tail, then that means Diego gets to go. And if there's 3 heads and 0 tails, then Jenna gets to go. Got it? Like, that's the only way of doing that, with having 4 categories. And they're going to use that to choose who gets to go. Does that sound fair to you? Like, does that sound okay?
Yeah.
I mean, it looks like it's going to be fair. Like, those are the only options that we have. Are you ready? Some people are over there like, I don't know about this. All right, so let's talk about our 3 coins here. Let's say that I'm flipping my 3 coins, and we said no heads, meaning tails, tails, tails. Who wins in that case if we get tails, tails, tails? Khalil. Okay, he wins or she wins. I don't know. Is that a boy or a girl? I don't know. If there's a tail, 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 right? Okay. And then if there's 1 head and 2 tails, then Amy wins. Okay, let's talk about 1 head and 2 tails. Head and 2 tails, right? Or let's say that it actually goes tail, head, tail. Or let's say it actually goes tail, tail, head. That's any of those 3 combinations are 2 tails and 1 head, true?
Yeah.
And who wins when that happens?
Amy.
Amy does. Does it look fair now?
What?
No.
Okay, let's go to the other options. So if we have 2 heads and 1 tail, Diego wins. 2 heads and 1 tail. That would be this combination. Or it could be this combination, right? Let's say I flip them in that order. Or let's say I flip them in that order. Are all 3 of those having 2 heads and 1 tail?
Why don't
The order
Doesn't.
doesn't matter according to who wins, but I could get any of those orders and it would be the same, right?
you could avoid all of this if you just have a random name
True, true. So they need to do this, this differently and not do it this setup, right? Okay, but they thought it was an easy fix by just doing it this way, right? Like, let's flip the coins and let's see what happens, right? Jenna only wins if I get 3 heads, so heads, 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 okay? That is the combination where Jenna wins, right? Okay, so out of this, how many total combinations are there?
6, 8.
8. Do you know where they get 8 from? What are the chances of me flipping a head to begin with? 50-50. So 1 and 2, or 1/2, right? But I'm doing that 3 times. So what's 1/2 times 1/2 times 1/2? 1/8, right? So each thing there's 8 combinations, or 8 ways of this happening. But the deal here is that Amy is just 2 heads and 2 tails and 1 head, which happens 3 out of the 8 times. Does that make sense? So Amy has a 3/8 chance, which is a 37.5% chance of winning, versus Khalil only has a 1 in 8, or a 12.5% chance. Does that make sense?
Yeah.
Okay, because of the order in which it occurs, right? Like, that's the way that it could happen. 3/8 is here. That would be 37.5%. And Jenna has a 1 out of 8, or a 12.5% chance, right? So if you do this over and over again, Amy and Diego are going to win the most often, correct? Right? So it looked to begin with like it was going to be fair, but it's actually not because there's more combinations that are like 2 heads and 1 tail versus all 3 heads, right? There's only one way of having all 3 heads versus there's a couple ways of having 2 heads and a tail, right? Or whatever, right? Does that make sense? Okay, so not fair. So we got to think about these things, okay? So, does Khalil's method result in a fair decision? No. Some have a 12.5% chance and some 37.5% chance of winning. Okay? That's what it boils down to. It's not just 4 options that are equally likely. It is actually 8 options that don't occur with the same frequency. So, like, that's not going to be fair. All right, now we got to think a little bit because part B says, is it possible for me to flip the coin 3 times? So we still want to try to flip the coin 3 times, but is there a way that I can flip the coin 3 times to make this a fair decision?
Just one coin. Just one coin.
You could do just 1 coin 3 times, but like how do I set that up to make sure?
Have each person have 2 of the, like, have 2 eights.
Right, like yeah. So like she's saying like these 2 would belong to Khalil, these 2 would belong to Amy, these 2 would belong to Diego, and these 2 would belong to Jenna. That would be okay. Like if we have that predetermined ahead of time. Okay? In the last period they said let's do it bracket style.
Yes.
Yes?
Yeah.
Can we do it bracket style? So, let my brackets go in the wrong direction. This way, okay? So we have Khalil facing Amy and then Diego facing Jenna, right? Okay? So I'm going to flip a coin here. And if it's heads, the top person wins. If it's tails, the bottom person wins. I'm going to flip it here also. Heads, the top person wins. Tails, the bottom person wins. Is that like fair? Is that equally likely to happen? That's 2 coin flips. And then whoever the winner is here is going to decide the overall winner. Would that be 3 coin flips?
Yes.
Yeah. Like, is that fair, though, all the way through?
Mm.
That would be okay. Everybody has an equal chance of happening. They've got to make it through 2 rounds, but they would have an equal chance of happening, right? Like an equal chance of winning. Make sense? Or like doing the whole rock, paper, scissors thing. That's why like that works. It's why rock, paper, scissors is like a bracket style, kind of, right? So that would be flipping 3 coins and having the same thing. Or like Megan said, you just want to make sure that when you separate it out, everybody has an equal chance of winning, okay? So that has to be fair, right?
You want to graph it like to the B?
What?
Draw it to the B?
Yeah, I don't know. I just did. Is it possible to flip a coin 3 times? I just drew the bracket. So use a bracket. Use a bracket.
Yes.
Okay, if you don't want to draw it out, you can write those words. Use a bracket style to decide the coin flip. Okay, make sense? So that would be an option, right? Rather than what they set up to begin with, which was not fair. This would be fair, right? Okay, next thing. We have owners of a candle making business and they're choosing suppliers of like their wax product or whatever, right? They have 3 suppliers and they're offering the same wax at the same price. So all 3 suppliers are exactly the same. Like, doesn't matter which one I choose, I have to choose one of them. Everything else is equally the same. Like if they were different prices, I would probably go with the cheaper one, or if like the wax quality was different, I would probably take that into consideration. But everything else is the same. And they want to randomly choose between the 3 of them using a random number generator that goes 1 to 1,000. Okay, but the problem here is, or what is the problem? Too many numbers, right? Like 1,000 divided by 3 is not a whole number, right? That's the problem. It's not equal to a whole number. So how do we do this? We still want to use our 1 to 1,000 random number generator because that's all that we have. We don't have like a coin flip or anything like that, right? We only have the numbers 1 through 1,000 and I want it to pick me a number. How can I design this so that it is equally amongst 3 of them? How can I do it?
1 to 3.
What?
Right? 1 to 3.
1 to 3. But what if you pick the number like 752? Who gets that one? Right? Like, you see what I'm saying? We have to assign the numbers 1 to 1,000 between 3 people or 3 things. How can we do that? Like, I could just choose the numbers, like, if we choose the number 1, if we choose the number 2, if we choose the number 3, but what happens if I choose the number 4? Or what happens if I choose the number 752?
We did like 1 through 3 and then 4 through 7, or 4 through 6 and 7 through 10.
Okay, I like your idea, but then 7 through 10, what happens if we get 11? We have to go all the way up through 1,000. If folks? Like, how do I do this?
1 to 330.
Okay, let's try it. Okay, I like this idea. 1 to 333. That would be 333 numbers. So if I pick out a number from 1 to 333, we're going with company A. Okay, when would we go with company B?
334 through 660.
334 through the devil's number. Okay, and then category C would be 667 through
100,000.
999. But what if we hit 1,000 on the nose? What if we like spin? And the chances of me hitting 1,000 on the dot is probably slim to none. But what if we do hit 1,000?
One if. Yeah, just
If hit 1,000 exactly. What if we spin and it pulls out the number 1,000? What do we do?
Go
spin
again.
again.
Spin again,
Yeah.
right? We could do that. We could say, as long as we specify that ahead of time, like if we hit 1,000 exactly, then we're going to spin again. That makes it fair, true? Everybody has the same number of numbers, same chance of happening. If we hit that other number, we're just going to spin again or pick a number again, right? Until we get a number that's not 1,000, and it is one of those three categories, right? What's the probability of A happening? 1 1/3, right? Or 33% chance, 1 1/3, 1 1/3, right? Everybody has an equal chance of happening because they all have 333 numbers, right? It's just that one number. If we end up hitting that number, we spin again, and that's no big deal, right? Like we could totally do that. Okay, so we make it fair by making it a number that is divisible by 3. True? Okay, all right, next. Last example, example 3. This one's a little bit more in depth, all right? So here we go. These probabilities are, this is a typo. I had to give you this information, and it's for some reason didn't get copied down. So copy these numbers down. You have to know this ahead of time. It wasn't in the paragraph, so I had to look this stuff up. You have to be given this information, and it didn't get copied onto this sheet. So 60%, 30%, 9%, 1%. Okay, here's what's happening. They used to do this with pop bottles, and they would put like points underneath of them. I don't know, maybe they still do. Like pop, no, they don't. Okay, you're looking at me like I have no idea what you're talking about. All right, so they used to take like pop bottles, like a Pepsi bottle or whatever, and then they would put like a code underneath of it or whatever, and then you'd go online and then you'd like rack up numbers or whatever, and then if you get to a certain number of points, then you'd get a free pop out of it or whatever, right? They're trying to get you to like buy more so that you like hopefully win more, but the company always designs it so that they end up reaping the benefits of it, right? So it's just forcing you to buy more pop, and you don't usually actually end up winning a whole bunch, right? So that's the way that it works. So this Citro orange juice has a cap with a number of points printed on the bottom, right? And the options of points, I could get 10 points on the bottom of my cap, or I could get 75 points. Now, which one is more likely to happen? Me getting 10 points or me getting 75 points? 10, right? Like they're going to put very few caps that have the big winners on the bottom of them, right? Because like they want to make money, okay? In fact, only 1% have the 75. That's 1 out of every 100 bottles that are sold have a 75 pointer on the bottom of it, right? Okay, 75 points occurs 1 out of every 100. That's 1%, all right? So here's the deal. We have a guy. And they tell you that as soon as you hit 100 points, so you rack up these points and you save all these bottle caps, and as soon as you hit 100 points, you can cash it in for $7.95, baby. Look at that. Woo! That'll buy you like one more pop probably, right? That's exciting. So 100 points gives you about $8. That's exciting. All right, this guy, Dalton, decides to pay $54, all right? So he's got $54, and how much is that buying him? You see? A case? 24 bottles. Okay? All right, 24 bottles for $54. That sounds like a lot. Like that's more than $2 a pop. Okay, so we're gonna see if the cash weighs out, all right? So I know that I'm gonna get points underneath of these bottles, like these bottle caps, but I wanna see if the number of points that I get and the amount of money that I get is going to like basically knock out the $54, right? Like is it gonna pay for itself? That's what we have to decide, okay? So let's look at this chart right here. And you remember when we did like weighted average? Right? Do you remember when we did weighted average? We were trying to like calculate like the number of words per minute times the student or the credits times the student, whatever. Okay, so we multiply these across, right? Equals. But 60% is actually 0.6, true?
Yeah.
30% is 0.3, 9% is 0.09, and 1% is 0.01, right? That's the way that this works, okay? So we're going to multiply those. What is 10 times 0.6? There's just 6, right? Do you know what 25 times 0.3 is? You can do this in your head. What's 3 times 25? Yeah, it's 75, so we move the decimal, so 7.5 is about 30% of 25. Okay, what's 0.09 times 40? 9 times 4 is 36. So is it 36? Is it 0.36 or 3.6? 3.6, right? You see how you do this in your head? Okay, what's 1% of 75? 0.75, so 0.75. Okay, now I add those all up. Whoa. If I add those all up, it is 6 plus 7.5 plus 3.76 and whatever. This ends up being 0.85. I know that. Carry the 1. I don't know, 17.85 is the number of points, okay? Now we have to divide by something. We're trying to find the average number of points, so I'm going to divide by this number. Okay, what does 0.6 plus 0.3 plus 0.01 plus 0.01 or 0.09 plus 0.01, what does that add up to be? 1. So I'm going to divide that by 1, which is just 17.85. So what does 17.85 mean?
The average amount of points.
It's the average amount of points underneath of one cap, right? On average, I'm going to get about 18 points per cap, right? Okay, so if I get 17.85 points per cap and I buy 24 of them, how much am I going to get in points-ish on average? Each one's going to give me 17.85 points or 18 points, and I got 25 of them or 24 of them. How much am I going to get? Multiply those together. Somebody got a calculator? 24 times 17.85. What do you got? It's like 428.4 points. So I can expect that about 428.4 points is what I would get in general, right? It might be more, it might be less, but about that is average, right? So how many prizes am I able to cash in? 4 of them, right? I can only cash it in until I hit 100 points, and I've hit it 4 times. So how much money am I going to make if I cash that in?
Like $40.
$31.80 is how much I'm going to make. Okay, so are the bottles of pop going to pay for themselves? If I'm trying to do this only to make money, am I going to make any money? No. Like I might buy 1 bottle of pop and win the 100 points or whatever to begin with or whatever, and then like be up ahead. But on average, I'm going to end up losing money because I spent $54. Now, they say, I don't know if you guys picked up on this, but they say in the last line, considering only the financial aspect of the strategy, is this a good decision? Why do they say considering only the financial aspect? Well, but you're getting the pop.
And then you're getting money back.
And then you're getting money back. So, like, you are getting the pop on top of this. So maybe you do think it's worth it if you like this pop. But if you don't like the pop and you're just doing it to try to make money off of it, are you going to make money?
No.
No. Off of 24 bottles, you're going to lose about $13-ish. Or $12, right? $12.20 is what you're going to subtract. You're going to be down about $12.20, right? Okay? So no, don't do this. No, don't buy the juice. No, don't buy the juice. If you're trying to do it to make money, like thinking it's going to make you money, it's not going to. That's the way they rig it that way. They do that on purpose.
Do you know what that even means?
Okay? Good? Happy with that? The last example is a contingency table. We're going to talk more about this tomorrow when we do a bunch of these. And on your homework assignment, all you have to do is, oh, there's a knot here. On your homework assignment, skills practice. You know the answer to the first one. It's not fair, evidently, but whatever.
No, that's fine.
Okay. Number 1, 2, and 3 on skills practice. And then on the back side, just do 1 and 2. Okay?
You could have just said don't do number 3.
So don't do number 3 on practice, basically. Okay? Now, most of these are just saying, is it fair, is it not fair, tell me why, right? Or how would you make it fair? So
I drank a little.
they are story problems, but they shouldn't be too bad. Okay? Do you guys have any questions before I stop? Okay.
I will.